vector here. It's a vector with two components, right? So when you chop it, you get a vector with one element and another subvector with one element. And there's two vectors here. So you actually have two of these subvectors and two of these subvectors, and you perform k-means for these subvectors. These subvectors, it would be like on this dimension, we're performing k-means along this dimension, which is right here, right? So there's a centroid right here. There's a centroid right here. If we're only looking for one centroid. Then so both of these vectors, they collapse to the same reconstruction centroids. So when you want to reconstruct these two vectors, they both reconstruct to this vector right here. So you can see how like this point moved pretty far, right? And this point moved pretty far. So maybe that's why recall's like messed up when you do PQ. Is I guess like some of these positions can be pretty far away from where they started. Then shouldn't you do PQ differently? Like, so what I was saying is like you should do IVF first. Which means like split up your space into categories. So you have these centroids for the categories. And then within each category you have several vectors. And then you perform PQ within this subregion, within this category only. So that you don't accidentally, because if you're performing PQ over so if you do PQ first and then IVF, then you're basically finding so let me fill the space. This is still in 2D. Okay, and here's our centroids. These are the centroids. Okay, so if you do PQ, like we're doing two-dimensional PQ, just like this. Then here's our two dimensions, right? And let's be silly and just do like let's do two centroids per dimension, right? Because well, I mean, it's not per dimension, it's per subvector, but we're dividing subvectors into one-dimensional vectors, so it's easy to draw, but so you'd have two centroids, right? So you're taking all of the vectors here, reducing them down, and looking only at their first dimension. So among all of them, there'd be two centroids. You'd have one centroid here, and one centroid here. And on this dimension, you'd have one centroid here and one centroid here. So when you reconstruct any of these vectors, all of the vectors, so let me draw so all of these vectors right, so you'd have like a region like this or something like that, and then all of these, well, it's confusing actually. So like there's really only there's 4 points. There's 4 possible reconstruction vectors you can get. When you reconstruct these vectors from their PQ values, these are the only 4 vectors that when you do a search, right? When you search over the database, you only actually see 4 vectors. all these green vectors got reduced down to these 4 red vectors. So this seems like a backwards way to do PQ IVF, right? You should do IVF PQ, not, right? Because if you, so what I'm trying to say is instead of doing PQ first and then IVF, if you do IVF first, then we can get rid of these. And so we do IVF first now, and we just look at only these vectors in this region right here. And looking at these only, we find 2 centroids for them. And there's 2 centroids on this axis also. So you just get four possible reconstruction vectors, right? Per region. So if we do this per region, we end up with like four of these dots per region. Right? So like here, like this, like all of, so you really have like all of the vectors around in this area get collated to this red point. So that's why if you have like a search, if your search parameter, if you're searching for vectors which are similar to this one, you would be finding like maybe, what if it's just outside? Let's say you're searching for vectors right here. Like you wouldn't get this vector. You wouldn't find it because it got moved over here. This one got moved over here. So it's just like, right? Like if we actually, to make it even worse, like if your search parameter is right in the middle of like these PQ reconstruction vectors, then you wouldn't find anything. It would be, everything would be equally distant apart, and so recall just gets completely messed up. Or it looks like it. You'd have to add more like PQ, more reconstruction centroids. But why not do it like this? I guess like recall would be slower, or searching would be slower. I guess searching this way is faster. And also like re-indexing would be slower doing this method, but I kind of want to use this method. I feel like I don't care if re-indexing is slow, and is search really that much slower? I don't think so, because to do search, you would first go to this centroid. You would go to this blue centroid first. You'd go here first, and then if your end probes is higher, you might check other regions also. Right, let's say your search parameters right here. So you would check all 3 of these centroids, and for each one, you would check these reconstruction vectors to see which reconstruction vectors are the closest, and you would find, you know, you would find these 4, right? So to me, that's what I want to use. I don't really like this method, but I'm not going to go and implement this. This is too much work. So I might implement this one day eventually if I really need to, but the idea that you lose so much recall doing this PQ first and then IVF seems unattractive to me. So I don't know, I might have to implement this eventually, because I feel like you would get pretty good recall percentages using this method. But yeah, it does come with some downsides. Search time is not a downside. I still think search is pretty fast. This uses up more memory, because like here there's only 4 PQ indices, right? But here you have 1, 2, 3, 4, 5, 6, 7, 8. But it could be double indexed, so you could have these IVF centroids as the first indice, and then the PQ indices as the second index. So it's double. It has 2 indexes, and you could still have a pretty. You could save bits still, I think, or a good amount of memory could be saved. And yeah, I don't know. I think this is a good way to do it. I'll be right back.